Math behind Michael Jordan's legendary hang time. Have you ever imagined if you could fly? Well, Michael Jordan, the king of basketball, flew from the free throw line, sailed across the sky, and dunked the basketball into the hoop. Well, that's what the basketball fan would say. Scientists would depict this historical, a legendary move like this. When you push against the ground pushes you up as Newton's dimensional third law of motion. By the law of inertia, the body soars through the air until the gravitational force becomes stronger than the force lifting the body, blah blah blah. To some basketball fans, this may seem like an insult to his magnificent dunk. However, without science, we wouldn't have been able to know the height and force of his infamous dunk. If you watched the video of his free throw line dunk, you might have been surprised that the time he spent in the air is shorter than you have imagined. In fact, his hang time was 0.92, less than a second. This is because the gravity doesn't let anything to be airborne for more than a second. As soon as you jump, gravity pulls you back down with the acceleration of 9.8 meters per second squared. Using what we know about gravity, we can drive a fairly simple equation that can model the maximum height off the ground. This equation states that the height of a falling object is equal to the object's initial height plus its initial velocity multiplied by how many seconds it spent in the air plus a half of the gravitational acceleration multiplied by the square of the number of seconds spent in the air. With this equation, we can model Michael Jordan's maximum height off the ground. His initial height would be, of course, 0 meter. The initial velocity of his jump was 4.51 meters per second. His hang time was 0.92 seconds, which means that he reached his maximum height at 0.46 seconds. The acceleration of the jump will be minus 9.8 meters per second squared. With all the clues, we can derive this equation. H equals 0 plus 4.51 multiplied by 0.46 plus half of minus 9.8 multiplied by 0.46 squared equals 1.03776. With this equation, we can know that his maximum height was roughly 1.038 meter. It seems as if Earth's gravity makes it pretty hard to jump high and get a solid hang time. So let's move the court into outer space. If the game was held on Venus, Michael would have jumped just a few more centimeters higher because of the low gravitational acceleration of 8.87 meters per second squared and get a hang time of 1.02 seconds. If the game was held on Jupiter, the game would have been dull because Jupiter has 24.92 meters per second squared. Here, Michael wouldn't even get a half a meter off the ground and remain airborne for 0.41 seconds. However, if the game was held on the moon, it would have been spectacular. Here, Michael can take off from behind half court, jumping over 6 meters high, and his hang time would be 5.5 seconds, making even scientists to believe that man can fly. Thank you for listening.